Hello, everybody. Thank you all for coming today. My name is Dan Robichaud-Carew. I am the head of product and software at Unspun. And what I'm going to share with you today is our vision for unlocking localized and on-demand production. Before diving in, I would be remiss not to give you all a quick reminder for why we need the fashion industry to change. Fashion is broken. In 2022, stores in the US were sitting on a record stockpile of over $732 billion worth of merchandise that was unsold. Global supply chain disruptions continue to threaten profitability. Textiles globally remain an economically important sector, but have a major impact on the environment. And even in the luxury industry, every year, brands are sitting on billions of dollars worth of unsold inventory. And we all know what happens to that inventory. It's typically landfilled or incinerated. Not only that, but we've seen an e-commerce boom, which has led to a mess due to returned garments going through the roof. In a recent briefing by the EU, it showed that 1 in 5 goods sold are returned online, and 70% of those are often discarded. These issues are both financial and ecological problems. So what do we at Unspun believe are the key forces driving us for the need for on-demand manufacturing and production? We believe it's complex and fragile supply chains, overproduction of unsold inventory, and overconsumption and online returns. For the complex and fragile supply chains, fashion has lead times of 15 or more months, and those lead times are often very not transparent. For overproduction and unsold inventory, we are just simply producing way too much. There are 100 billion new garments produced every year, and 30% of those are never sold. For overconsumption and online returns, 100 million tons of garments are discarded every year, and less than 1% of those are recycled. And I want to make it clear that I'm aware that these are very complex issues. Innovations for efficiency are only a part of the solution. There's no silver bullet here. Material and digital innovations are exciting, and they're a crucial piece to get us to where we need to be, but they only get us so far. And so that's why we at Unspun are thinking about the way that we manufacture and how we change that. And so there's a lot to unpack here. I'm really only going to focus on process innovations, on-demand manufacturing, and the potential for 3D weaving to curb the unsold inventory problem. There are a lot of amazing companies out there that are working on raw material innovation, but even if you can cut down total emissions and how much emissions go into creating a new product, even if you use recycled materials, recycled plastic bottles to make something new, the same problem still happens at the end of life. You've got overproduction and landfilling and incineration happening. And so that's why we're focused on innovating the process of manufacturing. This is what 150 years of innovation has looked like in the fashion industry, and there's reasons for this. And I'll go into that a little bit later. But our question is, what if we could make fashion on demand and close to home? Right now, the cost of inventory is one of, if not the most, the biggest inefficiency in the fashion industry. We believe that these issues could be solved with zero inventory, on-demand production models. In traditional manufacturing, brands are going to a manufacturing supplier and ordering tens of thousands of garments months to years in advance. They sit on these huge quantities of goods and are hoping for future demand that will meet those quantities. And that leads to an incredible amount of excess inventory. Our idea of on-demand manufacturing flips this model on its head. We minimize the need for pre-production and storage. The manufacturing process is initiated when there's a demand signal or when a customer orders something new, and that's when the garment is manufactured. This approach allows for greater flexibility and responsiveness to customer preferences. Products can be customized and tailored to demand signals. But how do we get there? It's a very difficult challenge. We've got these key blockers here. There's a lack of infrastructure. That lack of infrastructure has killed other companies that have tried to change the industry before, like RenewCell and other recycling initiatives. There's a high cost for adoption and a high cost to get to an economy of scale. And finally, there's labor issues. High cost of labor here in the West, as well as a lack of skilled labor here in the West has made it difficult to bring manufacturing back onshore. These issues are all interlinked with one another, and they block not only innovation, but the idea of on-demand production. And so the only way that we can get this transition underway is if we can balance sustainability and cost and address each one of these issues. So our vision for how you deal with the problem of lack of infrastructure is by building small, localized manufacturing hubs. The way you deal with cost is you combine multiple steps of the production process from many, many steps that bounce around all over the globe into much fewer steps that can be done in the same facility. And for dealing with labor, we're going to have to look at automation. So how do we do it? Our vision at Unspun is on-demand manufacturing with 3D weaving. 3D weaving is our game plan to decarbonize the fashion industry. We call our 3D weaving tool Vega, and we believe that it eliminates the need for larger order quantities and inventory while reducing lead times and transportation emissions. With Vega, you can go from yarn to a pair of pants in 20 minutes. You can spend 10 minutes weaving the pants and 10 minutes on finishing steps to finish the pair of pants. We call this yarn to you. And what I've got here is a video. I cannot actually show you the real machine. It's confidential. I need you all to sign NDAs to see it. But I can show you this sort of artistic interpretation of it and sort of explain what's going on as you watch. So we start with a spool of yarn. And we start with actually 2,600 of those spools of yarn, all coming in to the same core. There are shuttles spinning around those yarns, pulling them in together and forming this tube shape that you see here. This tube shape can be of variable diameter, which can create a taper, and you can basically make one tube for a pant and another tube for a pant. And then we perform finishing steps of sewing them together, and then you've got the finished pair of pants. So to review, 2,600 spools of yarn, they all come together to one core. They all get woven together into a tube. That tube can be of variable diameter and density. Each of those tubes are then taken together and sewn together. We take this complex supply chain, going from raw materials to fiber to yarns to creating the fabric to manufacturing, all the way down to warehousing, brands, retailers, customers, end of use. And we cut out a significant portion by being able to go from yarns to a fabric to a finished product all in the same facility and mostly with the same machine. So how is this implemented? How have we done it in the real world? We at Unspun have set up a microfactory. Our first microfactory is in Oakland, California. It's where I work. And we set it up to show the world how this process can be done. In our factory, we do R&D. We manufacture garments that we co-create with brands. And along with them, we hope to scale these microfactories around the world. We've got plans for next year, a fairly significant expansion into Europe, as well as we're hoping to expand into other parts of North America. In practice, you can think of it as sort of working like this. We've got our machine, the Vega machine, and this is part of it on the left. And then on the right, you've got automated finishing steps where garments can be sewn together, and this is just an example of what some of those machines look like and how that works. So what are the benefits of this? there's time saved. There's zero transportation and warehousing. Nearshoring is enabled. There's a faster process. You can weave these garments fairly quickly. There's less waste. There's a lot less waste than cut and sew production. This is a cost-effective model. It's risk-free because you don't have a huge amount of inventory in your warehouses. Reduces your reliance on long-distance transportation, such as air freight and all that. It's zero inventory, so 3D weaving enables manufacturers to reduce their reliance on high inventory levels. You might have to be ordering tons of fabric well in advance and sitting on that fabric just so you know that it's available for manufacturing, and this eliminates that need. You just go straight from yarn to finished garment. We believe it's a superior design with 3D weaving allowing for precise control. Every heddle on our loom can be controlled individually. That allows for very complex patterns. You can increase density in around the knees, and you can have interesting designs that you wouldn't really think possible before. And we believe that we can reduce returns with made-to-measure. And I'll go a bit into how made-to-measure works as well later on. Also, this is a relatively small footprint. We, with our 3D weaving tech, enable the establishment of microfactories. This is our vision for how manufacturing can move. 3D weaving enables on-demand production, so items are manufactured as they're needed, reducing excess inventory. And then, of course, there's circularity. So as you saw in that video, yarns are being woven in sort of a spiral shape. And when you have that, you can unattach that spiral, and you have a big yarn that you could reuse again. And I'll also go into some of the work that we've done there. So what can be made with 3D weaving? There's quite a lot of flexibility. We've got full jacquard control of every pick on our loom, as I mentioned earlier. We can have variable diameter tubes, so you can create a taper. We can deal with interesting yarn properties. We can work with cotton, tencel, wools, etc. And we've even done things with experimental materials like fishnet waste, and leather cords. It's very versatile. We've made a lot of really cool stuff. You'll see some examples here. These are some of the products that we've made on either our prototype or on our newer production level machine. We partnered with Eckhaus Lotte at New York Fashion Week, and all of these garments that you're seeing here were produced on our machines. So there's a lot of flexibility possible with these. We recently announced a pretty major partnership with Walmart, where we will be co-developing garments with them. So solving issues, fit issues with digital fit. I mentioned that, how do you actually create things on demand? So custom fit and automated patterning, a lot of what I spend my time on is the software side of things. And we've got technology where basically you can take a 3D body scan and we can form a pattern just for your body. This is live right now with our existing jeans product. And with this product, we've sold over 10,000 garments. We've achieved fewer than 10% returns on those garments. Our fit platform has a sort of a wide range of offerings. There is the fit recommendation side of things. You scan yourself and we say, yeah, this person should be a size 14S. Or fit visualization, where you can see during the design process where things might be tight, might be loose. And then finally, the custom fit side of customer takes a scan of their body and then we can generate a pattern specific to that individual. We've got a few sort of different ways that we work with businesses for this, being able to have these very easy to implement app clips where companies can implement having people scan themselves for the purposes of production. This digital supply chain, it starts with scanning, it moves to on-demand customization, and finally implementing with our microfactory of creating garments for people. So what's the impact? What's the sustainability impact of this? We have found that with zero inventory, zero waste, localization, circularity, Vega has the potential to reduce carbon impact of the fashion industry at a gigaton scale. It's a 53% overall reduction of CO2 for the lifetime of the garment. We performed a life cycle impact assessment where we basically compared two different pairs of pants. One, a 3D woven pair of pants that was built on demand. The other, a similar pair of pants that was made using a traditional air jet weaving technique and large-scale production. We identified key hotspots in the respective supply chains and provide recommendations. We estimate potential impacts and benefits of the two products and how circularity can help with the impacts. A life cycle assessment basically walks through each of these steps: raw material acquisition, manufacturing, distribution, end of use, and it analyzes what impact will each garment have on the environment. So what did we find? We found that if we used Vega to make products in bulk, we would see a 24% decrease in carbon emissions, 25% less energy use, and 1.4% less blue water use. If we made garments on demand, this was a second phase of our study, we see even larger increases in CO2, larger decreases in CO2 emissions, less energy consumption, et cetera. This is just showing that an unspun product, we're the bars on the left here, when looking at polyester and conventional cotton, and what the CO2 impact of unspun versus products that have an 80% sell-through rate, 70% and 60% sell-through rate made in a traditional manner. So on demand for the win here, right? We realized that with 3D woven pants, our project improved CO2 reductions by 29% compared with custom-made 3D woven pants, we reduced carbon emissions by 29%. The environmental benefits of on-demand production are quite clear. But we can't stop there. Of course, our goal is to be more efficient, but for us to drive impact, we need to build on this model. Circularity, as I mentioned, is something that we've looked at, and it's crucial. And in the coming decade, we believe that brands will need to have a much more clear plan for circularity. There's upcoming legislation in various jurisdictions around the world around circularity and cleaning up the supply chain. Most brands are already investing in circularity. Over 60% of fashion companies have already invested. We believe that by producing with Vega, we can account for and reuse our own waste. So with circularity by design, we take end-of-life garments and reweave them. We've performed our own prototypes of this, where basically we have a circularly woven garment, we recover yarn from it, we reweave it. And with 100% cotton that's made on demand on our 3D weaving machines that is circular, we then see a 62% reduction in global warming potential. With localization, we see even further reductions in global warming potential. This is setting up microfactories sort of around the world. Some other innovations that are inspirational to us. We've got by Bore here, and these are tools that, and Variant 3D, that their software allows any 2D model to be converted to a knit shape program and easily customizable for accelerated product development. Platform E, their technology helps with managing basically garment forecasting and leveraging technology to digitize supply chains with custom and on-demand production order management tools. Genealogia, we're big fans of them. They have set up their own sort of micro factories for developing a pair of pants. I'm going to try to wrap up here. So working with us, if anyone is interested in talking with us, The way that we work is first we start off with a co-development process where you get first access to Vega. We work together to develop a product together, something that is interesting. Then we perform a pilot. We create a few hundred pieces of those garments that we've co-developed, and then we work on scaling up and building a business together. And for manufacturers, we either can deploy machines in existing factories or build new microfactories from scratch. Our founding mission is to reduce global carbon emissions by 1%. We are a certified B Corp, and we're very proud of that. These are our founders. These are some of our partners that we are excited about. And that's it. So thank you all. Are there any questions? Yes.
How do you apply post-sewn finishes to garment, either like a piece dye, or even if the yarns have certain technology like stain repellent, any of that?
Yeah. So it really sort of depends on what the goals are. So performing those kinds of finishing steps. We've found that, for example, with Genealogia, they have some tech that lets you take a finished garment and dye that garment, and so that can help with if you only want to run one type of yarn through and then perform dyeing on it. We can work with sized yarns or unsized yarns, but I think there's still a lot of R&D in that side of the house for sure. Yeah.
Any plans to do things other than pants, tops, and...
Yeah, absolutely. So if you think of clothes, they're generally tubes. A shirt is a tube, a sleeve is a tube, and so the reason that we started with pants, our business originally was called Denim Unspun. Our goal was to really focus on denim first. When it comes to fit and finding something that fits people well, if you can make a rigid pair of jeans rigid fabric pair of jeans that fits somebody well, no matter what type of body they have, that was sort of considered our biggest challenge. And so we started with pants. It's really what we know best, but we are exploring accessories and shirts and other types of garments as well. Yeah. Yes.
When you talk about your material recovery, is that a specific type of fiber, or does that also include cotton and being able to recover that?
Yes. Yeah. When we have performed our own tests on it, we've mostly been working with cotton, of sort of unwinding the cotton and then reusing it. Yeah. Correct. Yeah, our focus is entirely on wovens. I think there's an interesting, potential future of sort of combining the two. But all wovens. Yes.
For the fit scanner, does it work for footwear?
Not at this point, no. Yes.
What is the output for the microfactory?
Finished garments. We most likely, in our current microfactory, we will be working with somebody else for finishing steps. But the microfactory, our vision for it is basically you create tubes, and then we sew those tubes together, and then you have a pair of pants.
Is there an ideal production number?
Oh yeah. So I had to sort of gloss over this. We've got in our microfactory, we have 3 machines that are capable of about 60,000 garments per year. Yeah.
How many shifts? One shift?
We've got one plus like a swing shift. Yeah.
Is it compatible with any 3D technologies like claw, browseware, style?
Yes, we are actively working on that. Right now, the way that it works is basically a brand will come to us with their design, and we have to sort of manually build a version that design a version that works on our machine. But we are very actively working on how do we take that CLO file or something along those lines, a DXF, and make it understood by our machine. Yeah. We have, yeah, we have. And I wish I had some examples, but we've definitely worked with stretch and had some pretty interesting results. And because we can change density and weave structure midway through, and we know exactly where that will land on the finished garment, we've been able to do some interesting ways of incorporating stretch in that way as well. Yeah. Yes?
Cost difference from regular manufacturing?
At this, our target is to meet the same cost. At this point, because it's still R&D, obviously it's more, but our target is to, reach the same price. Because we understand that even though the sustainability story is great, ultimately you're not going to, succeed. You won't win all the hearts and minds unless you can hit the bottom line. Yes?
I don't know if this is nitty gritty, but what do the seams look like? Is it like a full fashion type of thing, or?
The seams?
The seams of the actual product, yeah.
So there are no seams.
I mean, you're making two tubes. Putting them
Okay.
together,
Yes.
right?
Yeah. So like the rise, like there is a seam there for sure, and just
Is it
sort of
sewn, just-
yeah.
Okay.
Yeah. So yeah, and if, for example, a brand is interested in having the look of a seam, that is achievable with like basically kind of sewing in a dart or something like that. But we've found that there's some interesting things that can be done with seamless tubes. Yeah.
You don't have a sample? Show us today?
I don't. A lot of the rest of our team is at a different conference, and they've the Global Fashion Summit. So no. I am wearing the jeans that we've made. This was a test run, so it doesn't fit me super well. But I feel so bad, like just getting rid of it. So yeah. Yeah.
Are you guys still in like seed round, or are you guys fully in revenue now?
Yeah, we are Series A, and moving on to the next stage. Yeah. Yes.
How does the scanning technology work for customized fits?
Yeah. So we have a app that works on iPhones and potentially soon Android. We also have a physical scanner that we've used. So you could have something in store or on a phone, but basically you use this app. It uses the camera. The nice thing about iPhone cameras is they have like a depth sensor included, and so the person will set up their camera and sort of spin around in a circle, and then we use that to generate a 3D avatar of them with sort of thousands of points of measure that we then use to create the garment. And we've spent a lot of time over the years automating the process of how do you make something, because you can't just go from a size chart to, oh, this body is that size. Like getting fit right, there's sort of a lot more that goes into it. There is subjectivity, and so how do you make something that most people are happy with, that fits their body and their unique shape? And so yeah, there's been a lot of work that's gone into that. We're very proud of. My colleague here, Tori, she's the one who runs that project. Great. Anything else? And if you've got more questions, I'd be happy to chat afterwards.